Do you guys have a question? So this is now your chance to ask your question or queries, okay, regarding with our discussion.
None, sir.
All right. So again, it's already 12 o'clock, so you guys might want to get a food, okay, while having class. Well, in my case, what I do is I already eat, okay, earlier before our meeting, so that I have the energy to discuss the lessons lively. If I'm not mistaken, we were around 18, I guess, counts of participants in part 1. And right now, there's only 13. So where are the other 5? 14. Okay, so 4 more. Uh, all right. So let us now continue our discussion. So before we'll continue, is there any questions so far? Question or clarifications? All right, so maybe none for now, but a lot later on. All right, so if you guys do not have a question anymore, then all right then. Okay, so are we good so far regarding with octal number system? All right, so silence means yes, maybe. So my assumption. All right, so the next one here is hexadecimal number system. Okay, so as against me, although hexadecimal has a base of 16, so of course it's ranging from 0 to 15. However, we're going to use letters when it comes to 10 up to 15. Why? That is because 10, 11 up to 15 is already being used by octal number system. Okay, so to avoid duplications of characters or symbols, then we're going to use A as 10 for the hexadecimal, and then B for 11, 12 for C, 13 for D, 14 for E, and then 15 for. Right? So that is the reason why we have letters in here. So to count in hexadecimal, so yes, we have 0 to 15, but we don't have 16, 17, 18, and then 19. All right? So from there, you will jump to 10 to 19. sorry, we do have 16, 17, 18, 19, but that is another range already. Okay. So like for example, right here we have A to F as your 15. And then once we reach 16, right here, 16 as your decimal, we have here 10 to 19. And then for the 20 to 25, yeah, 20 to 25 is 1A, 1B, 1E, 1C, 1D, 1E, 1F. All right. And then 20 to 29 is still the same. However, when it comes to 30 to 35, it's now being represented by 2A, 2B, 2C up to 2F, right? So that is already quite a long range of number when it comes to hexadecimal. So don't you guys worry. Mostly, it's only below 15. Okay? Or if, yeah, there are some cases where it will reach up to 1A or 1B or 1F, but that is very, very rare, right? So for now, let's just focus with the basics, which is 0 to 9 and then 10 to 15. Okay. So the same with 0 to 9, but when it comes to 10 to 15, it's now being represented by A to F. Right? So are we clear so far regarding with hexadecimal? For now? Okay. So yeah, anyway, those are the only things that you guys need to know for now, okay? So hexadecimal 16, octal 8, binary 2. All right, so in here we can actually convert any base into decimal, okay? So this is how you do it. So to convert an integer number in any base to decimal, add all the products of each digit multiplied to its base in increasing power starting from 0. So take note that this is only for the integer number. For the fractional number, so you can convert this one also in any base to decimal. Just add all the products of each digit multiplied to its base in decreasing power starting from -1. So if it's integer, then increasing power starting from 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8. And if it's fraction, then it's decreasing, okay, starting from -1. So -1, -2, -3, -4, -5, -6, and so on and so forth. So yeah, I know that you guys are confused just by reading and understanding this one and how do we convert certain base to decimal. So this is the formula. Okay. So we have here the integer part, and then we have here the fraction part. Okay. So the first two steps that you guys will do is arrange this one from top to bottom. So we have here A, B, B, C, and then X, Y, Z. So it's from top to bottom, from highest bit to lowest bit, right? And then the next thing that you need to do is multiply everything to its base. So the base right here is could be binary, so times 2, could be times 3, times 4, times 5, or it could be up to hexadecimal. Okay, so it could be up to times 16. Okay, and then the numbers right here are the things that you guys need to worry about. Okay, starting from the decimal, so we have here the integer part. So again, it says here it's increasing power starting from 0. So 0 for the letter C, lowest bit of your integer. Next one is 1. The next one is 2. So 0, 1, 2. Meaning its base is multiplied, I don't know, the C is multiplied to its base raised to 0, and then base raised to 1, and then raised to 2. Okay, so that's it for the integer part. And then for the fraction part, so again, it is mentioned here that it is in decreasing power starting from -1. So -1, -2, and then -3. So that is why we have here raised to -1, raised to -2, and then raised to -3. Right? And then just do the math. Okay, just add all of them, and then you will get the answer for the decimal. Right? So for you to be able to appreciate this one, we have here an example. Okay, so we have A to F as your example. So we have here binary decimal. So how did I know that this one is a binary? Just by looking to its base. Okay, so as you guys can see, it has a base of 2, so this one is binary. This one is also binary. However, this one has a fraction part. Okay, this one is only integer, but this one has a fraction part. And then we have here octal. Okay, octal to decimal, octal to decimal, wherein the other one is or has a fraction part. And then the last two is hexadecimal. So hexadecimal, hexadecimal. But the other one is just or it has a fraction. All right. So here are the solutions of your letter A and B. So again, the first two steps that you need to do is just arrange this one from top to bottom. So 1 1 0 1 0 1. So 1 1 0 1 0 1, and then multiply everything to its base. Okay, so 1, so times 2 times 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 2, and then just start with the lowest bit. Okay, so this is your raised to 0, raised to 1, raised to 2, raised to 3, raised to 4, and raised to 5. Okay, starting from the lowest bit, so it's raised to 0, 1, 2, 3, 4, and 5. And then just do the math. Okay, you can use your calculator or you can do it manually, and then just add everything, and then you will get 53 base 10. So, were you guys able to follow?
Yes, sir.
Okay, so I'll give you guys 10 more seconds to analyze and recheck also at the same time. So I hope that you guys have your calculator with you so that you can recheck whether this one is really 53 base 10. So is our letter A correct? Is there someone who is checking whether this one is correct or no? No, guys. Guys, still awake? Guys, I need your feedback. Huh? So coming from Miss Jello, so she said that she got 62. How come? So we can actually check it right here, one by one. So 2 raised to 5 is 32. Could you please check that one? 2 raised to 4 is 16. 2 raised to 3 is, oops. Yeah, 2 raised to 3 is 2 times 2. What? This one should be 8. And then 2 raised to 2. I guess we're missing. Okay, we're missing the 8 one here. So 2 raised to 3 plus 8. So there should be plus 8 right here. And then plus 4 and then plus 1. Okay, and then of course this 1 is 0 since this one will be multiplied to 0. So 53 plus 8 is 61. Okay, so yeah. So very good, Miss Jello. Okay, so that is why your verifications is very important. So that is my way if you guys are really doing this one or no. Okay, so the correct answer or correction with this one, the correct answer right here is 61. Okay, not 53. Okay, so let us move on with the next one. So again, the first two steps that you need to do is just arrange this one from top to bottom. However, I didn't arrange it that way since we don't have enough space. So your one here is this one, yes. Your next one here is this one. Okay, so it's on the right side. Your zero here is this one. Your one here is this one. And then your, where are we? 1, 2, 3, 4. And then your one here is 1. 0 is right here. And then the last one is right here. Okay? But don't you guys worry. The process are still the same. Okay, so just multiply everything by to its base. So it's times 2. Okay, and then starting from the decimal, okay, moving to the integer part. So this one is raised to 0, 1, 2, 3, 4, 5, and then 6. So it has a maximum of 0 to 6. Okay, so 0 for the lowest bit, and then just keep on increasing by 1. So 1, 2, 3, 4, 5, and then 6. And then for the fraction part, so fraction part, naging utot na yung part natin. So this one is raised to -1, okay? And then the next one is raised to -2, and then raised to -3, okay? So it's right here. So -1, -2, and then -3. And then again, just let the calculator do the math, and you will get 109.625. All right? Ah, okay naman. Why did we miss that one? Okay, so this one is not 1. So 2 raised to 3 is, yeah, 8, but this one is multiplied to 0. So that is why we don't have 8 in here. So this one is correct. So yeah, the correct answer is 53. So again, correction. So this one is not 61, but this one is still 53. Okay, so this one is correct. All right. So thank you very much for that one, Mr. Ronald Glenn Hoggang. Yeah, I have a cousin whose name or last name is Hoggang. She's from Quirino province. For some reason, are you guys related with those people? Mr. Hoggang? Alright, I didn't know. Okay, so they are actually from, not really sure, but they are from Quirino, just near Isabela. Cordon, Isabela. Anyway, so yeah, the answer for the letter B is 109.625. Okay. So is Pinsan? May do you know someone whose Hoggang also wherein it is your cousin? Anyway, so mahaba na sa mga segue. Alright, so let's just focus with our discussion since we are very limited with our time. So were you guys able to get on how did we get 109.625? So yeah, I know that this one is quite long, especially if you're going to do this one with your calculator. So my only concern is for you guys able to follow the process and how to convert a binary into decimal. Are you guys checking this one? Okay. So, sakto lang, sir. So, yes, sir. Okay. So, I hope the others who haven't tried in computing this one and how to convert binary to decimal. So, just do this one once our class is done. So, all right. So, wait a second. So, Miss Jello said that she's confused that she's getting 108 or 109 or even 110. Okay, so it's not exactly 109.625. How about the others? Did you guys get the exact answer, which is 109.625?
Yes, sir.
Okay, so maybe you missed something. Okay, Miss Jello. Okay, so repeat it for now. Okay, I'll give you 20 seconds. So while we're waiting for your answer, okay, so you guys might be wondering, you guys will not be able to see the message of Miss Jello since it's a direct message. So if possible, just make the message into to everyone so that the others will be able to read your concerns also, so that they can help you. Okay, so we help each other in here. Okay. So again, we're waiting for her answer. So this is very important, especially if this one is a handwritten solution and answer. So you must not forget to put here the base 10. All right, so this is an indicator that we have already converted this base 2 into base 10, or this binary into decimal. Okay, binary to decimal. Okay, so without those bases, even though you've got the correct answer, you will still get a incorrect, or you will not get any points. Okay, your answer is still incorrect. Okay, so she said that it is now okay. Sure, pagbibilayan ba yung bit kasama yung fraction? Yes. Okay. So all of the characters in here is considered as a bit. Okay. So one bit, second bit, third bit, etc., etc., etc. Okay. All right. So let us now move on with letter C and D. So we have here the 4536. Okay. And then this one is octal. And then it is asking us to convert this one to binary, of course. Okay. So just do the same process. Just arrange this one from top to bottom. So 4536, and then multiply this one to sorry. This is not asking us to convert it to binary, but this one is asking us to convert it to decimal. All right, so sorry for that one. Okay, so your multiplier here is 8 because your base here is 8. Okay, and then again, just for you to be able to get this 0, 1, 2, 3 right here. So starting from the lowest bit, so this one is raised to 0, raised to 1, raised to 2, and then raised to 3. Okay, so that's how we've got those exponents. So raised to 0, 1, 2, and 3. And then just do the math, and then you will get this result, 2,398 base 10. Again, this is an indicator that we have already converted this octal into decimal. All right. So are we clear so far regarding with letter C? All right. And then for the letter D, we have here 127.4. So still the same process. Just arrange this one from top to bottom. So 1274. And then your multiplier here is 8. Okay, so times 8, everything. And then starting from the decimal, okay, so the fraction part is -1. And then from here, we have here 0, 1, and then 2. Okay, so we have here -1, 0, 1, and then 2. Then again, just let the calculator do the math, and then you will get 87.5 base 10. Right, so are we clear so far? Okay, very good. Okay, so the faster your reply, the faster that we'll be able to finish the module number 4, right? So your response is really, really important. All right, so here's the solution for letter E and F. So same process, okay? But in here, since we cannot multiply letter to a number, so we have to convert this letter into a normal number, which is 11. So B is equal to 11, and then F is equal to 15, okay? And then your multiplier here is 16 because we have a base of 16 right here, okay? So from here, we have 0, 1, 2, and 3. Okay, so 0, 1, 2, and then 3. And again, just let the calculator do the math, and then you will get 46,687 base 10. All right, so clear so far with letter E. So nothing has changed. It's just the bases, and then it's just the letter. All right, so if there is someone who is confused or who cannot get it, so just let me know, okay, so that we can discuss it again. All right, so for the letter F, we have here AC.E8. So still the same. A letter A is 10, C is 12, and then E is 14, and then 8 is still 8. And then your multiplier here is 16 because your base right here is 16. So again, from the decimal point, we have here is raised to 0 and then raised to 1. And then from the decimal again, moving to the fraction part, we have here -1 and then -2. Okay, so that's how we've got those. -2, -1, 0, and then 1. And then just do the math with your calculator, then you will get 172.9625. All right, so are we clear with letter F? Sir, di na pwede around. Well, since we don't have an instruction here instruction that need to run this one up, then no need. But if it's asking you to round this one up, then and you will only get 2 decimal places, then the result here will become 172.91. Right? So that depends on the instruction. Okay. So any questions so far up to this point? All right. All right. Okay, so next one here is n-based number system. So as you guys can see in our examples, it is only asking us to convert binary to decimal, octal to decimal, hexadecimal to decimal. If they are not covered with those bases, let's say base 3, base 4, base 5, then we call them n-base. All right, so an n-base can be any base. Okay? So it could be 3, could be 5, could be 9, could be 13. All right, so nevertheless, the it's n-base or binary or hexadecimal or octal, so the process is still the same. So you guys don't need to worry whatever is the base of that number system, right? So in here, the only thing that will change is of course your multiplier, wherein of course it's multiplied to 3. So still the same process, just arranges 1, 1, 2, 2, then multiply everything by 3. And then from here we have 0 and then 1, and then from here we have -1. Okay. and then just do the math, and then you will get 5.666666 base 10. Right, so the same with this one, okay, just a different base. So just arrange that one from top to bottom, 1, 2, 3, 1, and then multiply everything by 5. And then from here we have -1, 0, 1, and then 2. Okay, with 1, 0, 1, and 2. And then just do the math with your calculator. Then you will get 38.2 base 10. So are we clear so far with your n-base number system conversion? All right. Okay, if you guys have a question, so feel free to ask me anytime, all right? Clear so far, sir. All right, so very good. So we have here another example. So everything's still the same, just your multiplier, okay? So 8, 7, 5, 43, and then times 9 everything. And then right here is -1, -2, 0, 1, 2, and then that's how you got those exponents, okay? And then just do the math, and then you will get 716.48148 base 10, right? Yes, all of our meetings will be saved, so don't you guys worry. So you can always go back and then watch the part that you missed or you didn't understand that much. So yeah, I'll just put here. So all of our pre-recorded meetings is already in watch videos. Watch videos for module 1 and 2, and then watch videos right here. Watch videos on the module 3. And then later on, once we're done with our module 4, I'll put here the links of the watch or the links of the recorded meeting. Okay. All right, so yeah, that's it for the letter C. And then we have here another number, but of course another base. So we have here 1A7 or 110.7. So A is 10, and then B is 11. All right, so 110.7, 11 multiplied to 13, since that is the base of our number here, number system. And then just raise this one to -1. This one is 0, 1, and then 2. All right, so that's how we've got those exponents. And then again, just do the math, and then you will get 306.84615 base 10. So are we clear so far regarding with n-base number system into decimal? Okay. So anyway, do not verify whether this one is correct or no for now. What important is the process, the process behind and how did we get those answers. All right, and then supposedly this one will be your secret if we are in a face-to-face setup. But since we are not in a face-to-face setup, then I will not give this one to you as your practice activity anymore. Okay, so just do this one on your own. Okay, so if you want me to check your work, whether you made it correctly or no, so just send me a picture of your solution. Okay, so I can check it and then let you guys know if you're really doing the correct process. All right, so this one is 1 to 15. And then here are some of the things that you can also do, wherein you can convert a decimal into any base. So before we have converted any base to decimal, so it is now the opposite that we're going to do right now. So right now we can convert any decimal into any base, binary, octal, hexadecimal, or any base. All right. And then here are the steps on how to convert a decimal to any base. So repeatedly divide the given decimal number by the base where you want the decimal to be converted to until the quotient is 0. Step number 2, for each division operation, tally the remainder. And then number 3, if the quotient is already 0, write all the tallied remainders by reading them in upward direction. Okay, so again, this instruction is quite ambiguous, especially if we don't have the uh, example or the format. So that is why we have here the example for you to much appreciate this process that we have in here. So it says here, convert 13 base 10 to binary. So it's asking us to convert this decimal into binary. So here is a step that you need to follow. So let me just get this one. All right. So we have here convert 13 base 10 to binary. So the first thing that you guys need to do is get this one. So 13 and then divide it. Okay, divide it into the conversion that you want it to be converted to. Like for example, it's asking to convert this one to binary. So your divisor now will be 2. So if it's asking us to convert this one into, let's say, octal, okay, and then my divisor right here is 8. Okay, so as you guys can see, whatever is the converted or where it is asking us to convert it to, that will serve as your divisor. All right, and in here it is asking us to convert it to a binary, so our divisor is 2. Okay, and then we'll be having 2 parts for this one. We have the integer part and then the remainder part. Okay, so int for integer and then rem for remainder. So 13 divided by 2. So for the integer part, you will get here 2. Sorry, 6. So 6, and then we have a remainder of 1. Okay, and then the next thing that you need to do is copy the integer value that you have in here. So 6 divided by 2. 6 divided by 2 is 3, remainder 0. Then just copy this one. 3 divided by 2 is 1, remainder 1. And then just copy this one again. So 1 divided by 2 is cannot be. So just put here 0. And then whatever is the last value of your number right here, just copy that one as your remainder. And then once the value of your integer part is already 0, then that's the time that you will stop and then read the numbers from bottom to top of the remainder column. So your answer right here is 1101 base 2. Okay, which is now this one. All right. But then again, we don't have enough time anymore, so just wait for the part 3. Okay, so we will continue the rest on part 3. Okay, so goodbye for now and see you guys later on.